today's lecture we'll be discussing about the heart rate. Remember, measurement of the heart rate and identification of the cardiac rhythm go hand in hand. Measurement of the heart rate and identification of the cardiac rhythm go hand in hand because there are some abnormalities of the heart rate results from cardiac arrhythmia. That is why heart rate and rhythm go hand in hand. We discussed about the arrhythmia or the normal rhythm in a previous lecture in details. And right now we'll be discussing about the heart rate. When we are talking about the heart rate, we should think about the ventricular rate. When we should think about the ventricular rate, we should think about the number of the QRS complex which is produced within the 60 seconds. Remember, measurement of the heart rate is very simple and easy, and we can do with several ways. So before I start my lecture about the heart rate, it is very important that we have got a brief overview about the Ecg paper and Ecg machine. First of all, we are coming to the Ecg machine. What is the Ecg machine? This is 3 times that we discussed about the Ecg machine. Ecg machine is a standard electromedical instrument which records the electrical activity of the heart by drawing a trace over a moving paper. This was about the definition of the Ecg machine. Ecg machine is a standard electromedical instrument which records the electrical activity of the heart over moving by drawing a trace over a moving paper. Ecg machine, standardization of the Ecg machine is characterized by 2 things. One is constant rate, another is calibration signal. What does it mean, constant rate? It means all Ecg machines are adjusted in such a way that the 300 large square move under the needle of the Ecg machine within 60 seconds. So 60 seconds equal to 1 minute and 1 minute equal to 60 seconds, or vice versa. Or in addition, that 5 large square which represent 5 large square when move under the needle of the Ecg machine, it takes how much time? 1 second, or vice versa. So we have right now understood about the Ecg machine and Ecg machine. The second thing which represent calibration signal. What does it mean, calibration signal? A standard signal of 1 millivolt displays the needle of the Ecg machine vertically up to 2 large square, which represent 10 millimeter, which represent 1 centimeter, or finally which represent 1 millivolt. So during the taking of the Ecg, you should include it in each taking of the Ecg calibration signal. This was about the standardization of the Ecg machine. A standardization of the Ecg machine is characterized by 2 things. The first, constant rate, constant speed. It means 300 large square moves under the needle of the Ecg machine within 60 seconds. So 60 seconds is equal to 300 large square, and 300 large square equal to 60 seconds, or vice versa. Or in addition, the 5 large square. 5 large square when move under the needle of the Ecg machine, it takes 1 second. So 1 second is equal to 5 large squares, and 5 large squares is equal to 1 second. Another. Right now we will be discussing more or less about the Ecg paper. This is the 2 times that we discuss about the Ecg paper. To get better idea about the heart rate, we must know about the Ecg paper. Ecg paper is a thermosensitive paper. It means when the needle of the Ecg machine heated, this heated needle moves over the Ecg paper, and by drawing a trace, they produce Ecg. This was about this Ecg paper is made from large square as well as small square. The large square duration takes 0.2 seconds. 0.2 seconds. And the small square will move under the needle of the Ecg machine. It takes 0.04. What are those mechanisms by which 0.2 and 0.4 is produced? It is very easy. As we know, 300 large square moves under the needle of the Ecg machine within 60 seconds. 300 large square of the Ecg machine is moved under the 60 seconds. 1 large square X We know that we don't know the duration of the large square. So 300 large square move under the needle of the ECG machine within 60 seconds. One large square, how much time is taken when move under the needle of the ECG machine? It is x. X is equal 60 divided by 300. The one large square mechanism which is produced is 0.2 seconds. The duration of the one large square represents 0.2 seconds. Right now we will be discussing about the 0.04 seconds. One large square include of 5 small square. So 5 small square and 1 large square equal to 0.2 seconds. So 5 small square, 5 small square.
0.2.
Here? Yes. 5 small square equal to 0.2 seconds. 1 small square x. 0.2 is divided by 50. 2 over 50. 2 over 50, 2 is less and 50 more. We present here a point and then 1 0 and another this. The second 0, the total it makes 200. When 200 is divided by 50, it shows 0.04 seconds. So the standardization of the ECG machine is characterized by 2 things. One is constant speed or constant rate. We should know these things, especially constant rate. We should memorize that the 300 large square of the Ecg paper move under the needle of the ECG machine within the 60 seconds. 60 seconds equal to 300 large square or 300 large square equal to 60 seconds. One large square have got the duration of the 0.2 seconds. One small square have got a duration of 0.4 seconds. The basic building unit of the ECG represented by small square. When we use it for duration of the wave segment and interval, we should use the 0.04 seconds. Just you should memorize 0.04 seconds. This was about the ECG machine and ECG paper. This horizontal line of the ECG paper represent time duration. And vertical line represent amplitude, which is measured by millivolt. In simple, the horizontal line represent time and the vertical line represent the amount of the voltage which is produced by the heart. This was another thing which is very important during discussion of the ECG. When we want to learn about the heart rate, we should know about the ECG paper. If we don't know the ECG paper, we will not calculate or we cannot get exact number about the ventricular rate or heart rate. And as I mentioned before, when we are talking about the heart rate, we think about the ventricular rate. When we are talking about the ventricular rate, we should think about the QRS complex, which is produced by depolarization of the ventricle. As I mentioned before, measurement. As I mentioned before, measurement of the wave segment and interval is easy and simple and can be done by several ways. And one of the ways right now we'll be discussing here. If the heart rate is regular, we can easily get information about the rate of the heart. For example, you suppose this is a normal ECG, and between these 2 normal ECG we have got 3 large squares. If the rhythm is regular, we divide the number of the large square over 300. Or 300 should be divided by the number of QRS complex which is located between 2 RRMs. For example, this is 1 QRS complex, 2, 3. 300 should be divided by 3. It will immediately give for us heart rate. What is the mechanism by which this 300 over 3 is produced? Since we know for 3 QRS complex, for 3 large square we have got for 3 large square. For 3 large square, we have got 1 QRS complex. For 3 large square. For 3 large square, we have got 1 QRS complex. In the 300, how much? X. We should 3 come here and 30 goes there. This was the mechanism by which we divided rapidly and fastly 300 by 3. This is the mechanism. Did you catch this one? Yes. If the rhythm is regular, the measurement of the heart rate is very easy because the number of the large square should be divided by 300. it gets rapidly and immediately information about the heart rate. It is easy. If the heart rhythm is irregular, for example, a patient have got atrial fibrillation, how should I determine the heart rate of those people who have got abnormal rhythm? For example, this patient have got atrial fibrillation. The RR distance is not equal. So in such a cases, we count the number of the QRS complex within 30 large squares. Large square.
6.
So if the heart rate is irregular, we count the number of the QRS complex over 30 large square. Right now we know this 30 large square represent 6 seconds. Good. 6 seconds. In 6 seconds we have got, for example, we have got 12. In 6 seconds we have got 12 large square.
QRS complex.
Okay, QRS complex. And 60 seconds, X. This 6 second here, 60 times 1, 12. 6, 10, 100, 200. This was about the, if the rhythm is irregular. So if the rhythm is irregular, for example, patient have got atrial fibrillation. We calculate or we measure the number of the QRS complex over 30 large square. Since we know 30 large square equal to 6 seconds. And in the 6 seconds we have got 12 QRS complex. In 60 seconds, X. In 60 seconds of this, we have got 120 rate. In addition to that, we have got a very rapid or quick method. This method is called memorizing method. In this memorizing method, we should not forget the triple. For example, 300, 150, 100, 75, 60, and 50. For example, in this case, this is the start line, we should omit, and we start from this case. First 300, 150, and 100. This is a rapid method. If there is a bradycardia, we also another triple is also add. For example, 75, 60, and 50. So the rapid method is 300, 150, 100, 75, 60, and 50 beats. So we introduce here 3 methods. When the heart rate is regular, the number of the large boxes is divided by 300. If the heart rate is irregular, we calculate or we measure the number of the QRS complex over 30 large square. 30 large square represents 6 seconds. In 6 seconds, we have got 12 QRS complex. In 6 seconds, in 60 seconds, which represent 1 minute, we will have got 120 heart rate or beat per minute. Another triple method, memorizing, another regular, irregular. So, whichever method we use, guys, whichever method we use for calculation or for measurement of the heart, you should not forget the atrial rate. Whichever method we use during the measurement of the heart rate, we should not forget atrial rate or P rate. Because sometimes we are facing to cases that the patient have got atrial fibrillation. The P wave rate is quite different from ventricular rate. For example, in case of the atrial fibrillation, we have got 350 beats, atrial beats. All of them does not go to the ventricle. So in these cases, just AV node can conduct 150 beats per minute. More than 150 beats per minute, AV node is not able to conduct the electrical impulse from the atrium into the ventricle. So in case of atrial fibrillation, for example, the heart rate is 350 and the ventricular rate is 150 or 170. Did you get the last things? So in whichever method we use to get the information about the heart rate, you should not forget the atrial rhythm. Atrial rhythm sometimes is quite different from the ventricular rate. For example, in case of the atrial fibrillation, we have got 350 impulses. This 300 impulses should go down, but the AV node does not allow for these 300 to go down. If this 300 atrial impulse goes to down, what will happen to the ventricle? VTAC is produced. Because ventricle is pumping empty, and the cardiac output is low. That is why the AV node has a major role for the controlling of the ventricular rates, especially the ventricle has got the ability to respond to 150 or to 170. More than that, the ventricle may be irritated, and the ventricle is finally produces ventricular tachycardia. After the ventricular tachycardia, ventricular flutter and ventricular fibrillation, and finally the patient may develop arrest. This was another very important that we should pay attention about. When you want to measure the ventricular rate, we should immediately think about the atrial rate. Atrial rate without the ventricular rate, they say it is impossible. You should count the ventricular rate, and immediately you should count after the ventricular rate, atrial rate, or P per minute. After that, you understand about the heart rate. Two old and classic things should not be forgotten. One is tachycardia, another is bradycardia. More than 100 beats per minute, it is called tachycardia. Under the topic of tachycardia, we will be discussing about the sinus tachycardia, atrial tachycardia, atrial flutter, atrial fibrillation, and atrial fibrillation. Another the ventricular tachycardia, fibrillation, accelerated ventricular rhythm, and Sulfur's point. This comes under the topic of the tachyarrhythmia. Under the topic of the bradyarrhythmia, for example, nodal sinus bradycardia, 6 sinus syndrome, which represents sinus arrest, 2nd degree and 3rd degree nodal block. After we come from the node, we will come to the AV node. AV node, 1st degree AV nodal block, 2nd degree AV node, 3rd degree AV nodal block. After that, we can come to the bundle branch, left bundle branch, right bundle branch. Finally, we will come to the fascicular, anterior fascicle block, posterior fascicle block, and finally, we will be discussing under the topic of the bradyarrhythmia two another things: AV nodal escape rhythm and ventricular escape rhythm. These matters should be one by one is explained under the topic of the bradyarrhythmia. Under the topic of tachyarrhythmia, we will discuss about the sinus tachycardia, paroxysmal atrial tachycardia, flutter, atrial flutter, fibrillation, AV nodal reintent tachycardia, AV nodal and intranodal or AVNR ventricular tachycardia should not be forgotten based on tachyarrhythmia and bradyarrhythmia. Those people who have got bradyarrhythmia, the heart rate is less than 60, we say this patient have got bradyarrhythmia. If the person have got the heart rate more than 60, this is called tachyarrhythmia. Remember, rate and rhythm should not be forgotten during the measurement of the atrial, about the abnormal rhythm. So rate and rhythm works as a two brothers. They have mentioned. When somebody asks you to give me the definition of the arrhythmia, you should easily answer for them. Abnormality in regarding of the rate and rhythm is called arrhythmia. Rate without rhythm produce abnormality, and rate without the rhythm also produce abnormality. So rhythm and rate, both of them, 100% condition for the measurement of the arrhythmia, as well as whether it is tachy or brady. Dysrhythmia, it is better to say dysrhythmia. This was in today's lecture about the ECG, about the heart rate. In the previous lecture, we discussed about the cardiac rhythm. Right now, you will again